Okay, third time's the charm. Okay, so we are talking about writing proofs for congruent triangles. So with proof writing, there are a couple of things that you need to be aware of. You have to be really careful. So the big thing with proof writing is you're always answering the question, why? Okay, anything you write down, you have to say why. It's like having your annoying little brother or sister that's asking why about everything. You have to write everything down. Okay, and the reason we're doing this is we're trying to the goal that we're trying to get at is the logical processing of being able to justify every step of a justification. Okay, well, every step of proving something correct or whatever you want to say, following through every single step. Okay, so this is a big thing. Why? So a couple of things that I want to talk about just before we get into this little paper is you're gonna have statements for your proof. So that's where you say what's happening, and then a second column that's just reason. So right next to everything you write down, we have a reason. Okay, so I can't think of an example. The first reasons are always going to be given because you're going to be told some things that are true just right off the bat, and you get to write those down first. So maybe you're told, angle A is congruent to angle C. The problem just says that. And so you get to write given. But then, later on, once you've written down all your givens, maybe you have a few things that they give you, and then you see some vertical angles and you want to mark them down as being congruent. And so you'd be like, angle B is congruent to angle KLM because of I said vertical angles. Okay, so you have to justify everything, and you'll have a goal that you're trying to get to prove. Okay, so you need to make sure you write down everything. So one of the things I want to say is just make sure to write all of your givens first. Okay, those are going to be the first things you write down, and then when you get to the end of the proof and you've proved what you were set out to prove, then you finish the proof by putting a little box like this. I'm not lying, this is a real mathematical thing. We just put a little box like that, and that says it's wrapping up all your proof in a little box, being here you go, I did it, it's all there. Anyway, so what this document that you should be holding, what we're going to fill out, that says congruent triangle proof reference sheet at the top, it's going to give you a list of almost all of the reasons that you might use in a proof. Okay, so it's kind of like just a word bank that you could look at and get ideas for your proof. Okay, there are a few others that won't be on there, but these are the most common ones. Okay, so what I'm going to do is we're going to go through each of these, and I'll give you an example of how it would be seen in a proof. Okay, so the givens always come first. So when you have your statements and your reason, the first couple are always going to be given, just whatever they tell you it is. You write them down as given. So if they tell you 3 things, you have 3 lines that say given. If they tell you 2 things that say given. So I'm just going to write a note that says write these first. You write them down and then mark them on your diagram. Notice I said write them down first and then mark them so that you don't forget to write them down. Okay. So we're really just formalizing everything that we have been doing for the last few days, and now we need to write everything down that goes through our brain. So the next reason we're going to look at is called definition of midpoint. So what this would look like if I was writing it, if I wanted to use it in the middle of a proof. So I've already written down my givens, blah, blah, blah. So I would have written down this as a given and this is a given. So I'm already 2 lines in just for the sake of this video. I'm not going to write all those down. And then I realized it says C is the midpoint of AD. So here's point C, here's AD. And they tell me C is right in the middle. And so what I know because of that is that AC is congruent to CD because it's the midpoint. So it breaks those 2 into equal parts. So what I would write down is that AC, my statement is that AC is congruent to CD. And the reason is definition of midpoint. So if your younger brother or sister was watching you do your homework and you marked AC's congruent to CD and they were like, what, why? Your reason would be, well, because C was the midpoint. So it's definition of midpoint. Fresca. Okay, so that's definition of midpoint. Definition of perpendicular. Okay, so if I was in the middle of a proof and I wanted to use this, so I've already got my givens in here. I've written down everything they gave me. And whoops, I wanted to change color. Okay, so one of the things they gave me two things. They said XZ bisects angle WXY, and XZ is perpendicular to WY. That's the perpendicular sign. So I've already written those two things down, pretend I have. And now I want to say, like, okay, XZ, that's this one, is perpendicular to WY. So what I know that means that these are right angles, okay? So what I'm going to say is that angle WZX and angle XZY are right angles. They're right angles. And my reason is definition of perpendicular. That'd be my reason, the definition of perpendicular. And then since I know they're both right angles, probably my next step, at least in this case, is going to be say that those two angles are congruent because they're both right angles, right? And so what I would say is that now I would come in and say WZX is congruent to angle XZY. And my reason would be that's called the right angle congruence. Right angle congruent. So really that should have its own box, but I just thought I'd put those together. The definition of perpendicular makes them right angles, and then because they are right angles, then they are congruent. So I would have these two steps and then you could carry on, okay? But those are definition of perpendicular, okay? How about definition of segment bisect? So here I am, I'm in the middle of a proof, justifying my whole step, trying to prove these two triangles are congruent. And I've already written down my givens, so I'm going to put ... so you can pretend those two things, 1 and 2, are already written down as givens. And now I want to use the fact that BE bisects AD. So here's BE, it's cutting AD in half, okay? And so what that tells me is that AC and CD are congruent because it's bisecting it. So my statement would be BC is congruent to CE, and my reason would be definition of segment bisect, just like that. And yes, you have to write it all out. Sorry, I need a little bit of a smaller line. And then I would keep going with my proof, whatever else I was trying to prove. So maybe you could get some vertical angles in there, and maybe you'd be ready to go after that. Okay, next we're going to talk about definition of angle bisect. So I'll use my little setup, my statements and reason. I've already listed my givens. They'd be, well, actually there's just one given, AC bisects angle BAD. And so AC is this, it's bisecting angle BAD, which is this one. So that means it's splitting this up into two equal angles. So my statement is going to be that angle DAC is congruent to angle BAC. So those two little angles. And the reason I know that, so your little sibling goes, well, why? You say, well, because it's a bisector, and that's the definition of angle bisect. And then I would carry on with my proof, whatever other things I needed to use, okay? All right, here are vertical angles. We love our vertical angles. So what would that look like? My vertical angles, okay? So I've already listed, I would list my two givens here, the BE bisects AD and the angle A is congruent to angle D. So I'd already have those down. And I'd be like, what else I can do here? What else can I do? What else I can do? What else can I do here? And I'd be like, oh, what? There are vertical angles right here. So the statement I would make is angle BCA is congruent to angle DCE. And my reason would be vertical angles. Because vertical angles are congruent. And then I could keep going with whatever else I needed. Okay. All right. With alternate interior angles. Okay, one thing I need to mark, and I'd like it if you marked or wrote this down on yours too, is that for alternate interior angles, we have to have parallel lines. So you must have parallel lines. Like that has to be given to you, that there are parallel lines, or else, well, they're not alternate interior angles because that's only a rule for parallel lines. So when I write my givens, like for here, one of the givens was that AC is parallel to DB. So just for the sake of this problem, I'll go ahead and show you, I'll write those out. So I'd write out my givens. I'd say AC parallel to DB. The reason would be given. And then I have angle A is congruent to angle D. That's given. Then I would go ahead and mark these on here. So AC is parallel to DB. I mark that with arrows, not ticks, because that means they're congruent. These are just parallel. Angle A is congruent to angle D. Okay. And the thing that we're trying to look at here are the alternate interior angles. So I'm looking for that Z shape with the two sides being the parallel line. So it looks like this. So I can say that this angle and this angle are congruent. So that's going to look like angle ACB is congruent to angle CBD. And the reason would be alternate interior angles. Alternate interior angles. And then we can move on with whatever else we need. We could do a reflexive property there. Some other stuff going on there too. Okay. Awesome. So you just have to make sure that this has to come, the parallel statement has to come before the alternate interior angles because these are coming in order. Okay. All right. Next, there's our reflexive property. We've been waiting for this one. This one's my favorite, I think. So we would list our givens. So in this case, it's just the diagram. So they didn't give us any givens, but now I'm looking at this and I say, well, what can I say? I can say that this side is shared by those two triangles. So my statement would be that BC is congruent to BC. And the reason would be reflexive property. Reflexive property. And then I would keep going with whatever I was trying to prove. Okay, this is the last one we're going to talk about in this video. So we have our 4 ones that we've been working with. And so I'm just going to pick one of them. I'm just going to pick this one, I don't know, and do an example. So down here, if I was doing my statements and reasons, okay, one really important thing, and I'm going to emphasize this again later, is that before you can use, so like this is going to be side angle side. I'm about to use side angle side on this. So I would write like triangle ABC is congruent to triangle. I got to match these up. DFE, they're already lined up. My reason would be side angle side congruence theorem. Like so. And when I see side angle side, or when I write side angle side, that means that there has to be at least 3 things above this line, because there needs to be a side, an angle, and a side congruence. So there's have to be at least 3 statements: a side congruence, an angle congruence, and a side congruence. And that's just one way to make sure that you have everything you need, is that those 3 things should be listed there, either as givens or things you figured out from the reflexive property or vertical angles or something like that. So those 3 sides, and we'll show that again. Okay, we are going to come back to the CP/CTC. I'm going to do a part 2 that you'll look at tomorrow. So that's this whole front page here. So these are all different possibilities for the reason that you can have. Okay, so we're going to do 3 examples on the back here that we are ready for. So here are our givens. This is actually just one giant given. It's that CA is congruent to CB, which is congruent to CD, which is congruent to CE. So these 4 line segments are all congruent. You can kind of see the tick marks right there. Okay. So since they gave that to us, we need to write this down as our first thing. So it's going to be CA. CA is congruent to CB, is congruent to CD, is congruent to CE. And when I grade these tests, I'm going to be so particular about the line segment lines being on top and the congruent symbols looking good. Like, you have really got to impress me. Okay. And the reason for this would be given. They told us this in the first place. So that's my first line. And then I like to look at what they asked us to prove. So they asked us to prove that triangle ABC, which is this triangle ABC, is congruent to triangle EDC, like this, okay, which I think is reasonable. So I just like to get it in my head, like, what am I trying to prove is congruent? So those 2 triangles, that seems reasonable. So I've written down all my givens, and that's not enough information to say that it's congruent because I just have sides. And what I'm noticing here is I have that like bow tie shape, like the X. So I could say that those 2 angles are congruent because of vertical angles. Now it looks like a TIE fighter. I'm going to write that as angle ACB is congruent to angle DCE. And the reason would be vertical angles. So there's another line. Okay, so now I have side, angle, side ready to go. Like, look at my drawing. I drew that all. I'm ready to go side, angle, side. So the nice thing about this is that my last step, like your last statement, should just be the thing you're being asked to prove, because that's your final statement. That's what you're trying to get. So they've already written it out in order. Triangle ABC is congruent to triangle EDC. And the reason we got was side, angle, side congruence theorem. Great, and that's the end of my proof. So I'm going to finish it up with a little box. I proved what I was trying to prove. So like I mentioned before, we want to make sure that everything is there. So I use side, angle, side. Here's an angle congruent statement. And this one is kind of interesting because this one encapsulated like two, because it had so many going on. So that had both of the sides and that had the angle on it. So that's how we were able to get side, angle, side. Okay, so I guess I say there should be at least 3 lines before, but that one line was like so much that it actually didn't to itself. Okay, all right, next one. It says given. So JK parallel to ML, given. And MJ is parallel to KL is given. So those are 2 givens. We have both of them down right there. Great. And we are trying to prove that triangle MJK, so MJK is this one, is congruent to triangle KLM. Yeah, that seems reasonable. Just want to make sure. Sometimes there'll be like multiple triangles or whatever within your problem. So you just want to make sure that you're actually like looking for the right ones. Okay, so I've got my givens. They're just parallel lines. So I don't have any congruent statements at all right here. So I'm looking at my picture and I see those parallel lines. So chances are we're going to use some alternate interior angles. But first thing I notice that I have that MK shared side. So that's the reflexive property. So I'm going to write MK, which is congruent to MK. And then my little sibling goes, why? And I say, well, because of the reflexive property. Nice. So now I have a side. Obviously, that's not enough. We need some angles, but we are going to use those parallel lines, right? So my first set of parallel lines forms this Z. So I can see that this angle and this angle are the same. So I'm going to name that angle JKM is congruent to angle KML. And my reason would be alternate interior angles. Great. And then I can also come in the other way. And I have this parallel line making a Z down here with that parallel line. So then I can see that this angle and this angle are congruent. So that's angle JMK is congruent to angle LKM. Also because of alternate interior angles. Got kind of lazy with my angles there, but I do like the colors that are happening here. Okay, so I think we have enough now, because if I look at this triangle, I have angle, side, angle. When I look at this triangle, I also have angle, side, angle. So we are ready to go. And remember, I'm going to look at how they wrote it. Triangle MJK is congruent to triangle KLM. Okay. And the reason there was angle, side, angle. Congruence theorem. So I'm going to go off the box. Ugh. Angle, side, angle, congruence theorem. And that is the end of that proof. So I'll put a little box on it. That was a longer proof, but we made it there. So I'm just going to double check, because I said angle, side, angle. So I better make sure that everything is there. Here was an angle congruent statement. Here's an angle congruent statement. And here was a side congruent statement. So they don't have to come in order. We just need to make sure all 3 of them are there. Okay. So we have all 3, both angles and a side there. Okay. Last one. So let's write down our givens first. They said given that QR is congruent to RS. Given. And then angle P is congruent to angle T given. Okay, then I'm just going to trace and make sure I know what's happening. They're asking us to say that triangle SRP, there's triangle SRP, is congruent to triangle QRT. I'm going to highlight that and go QRT. So there are two triangles we're trying to prove are congruent, that blue one and the pink one there. And they've already told us, I'm going to mark what they gave us, QR, which is part of the pink triangle. So maybe I should mark that pink, is congruent to RS on the blue triangle. And then also angle P is congruent to angle T. So we have a side and an angle on both of those triangles, and that's not enough. So looking at this, I see that they share an angle because they overlap right here at the top. So they both use that angle R in them, the blue triangle and the pink triangle. So I'm going to say angle R is congruent to angle R. And the reason for that would be the reflexive property. Uh-oh, maybe I shouldn't have drawn my line so soon. Okay, we made it. Okay, so I have my reflexive property. And now I think I already have enough because it might be helpful. It helped me to kind of separate these out as if I could pull them apart, the pink and the blue ones, because this is like point P, this is R, this is S, this would be Q, R, T, and see how they line up. So you have an angle, the side on the blue and that angle, and then on this one we have angle, the side, and the angle. So we have angle, angle, side set up for that one. So I'm just going to write triangle SRP, just like it says at the top. Triangle SRP is congruent to triangle QRT, and my reason would be angle, angle, side congruence theorem. Now I'm just going to double check because I said angle, angle, side. So I should have angle, here's another angle, here's a side. Great. So all three of those statements are there, angle, angle, and side. Okay, that is enough information to do the first of your purple of the prove it worksheet, like front, back, and front. Okay, front, back, front on those. All the ones where they're kind of started giving to you, they have the table and everything. Be careful, make sure you write your givens first, make sure you're writing everything down, and they're kind of like half filled in. So you really have to make sure you're like following along, make sure you have the right things in there. Check with your neighbor, make sure you've got everything there, double check that you're getting like, you know, the side and the angle, like all three things that you need to get before you can use angle, side, angle, or side, 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 or whatever it is. Double check those in there. Okay, good luck, and yeah, enjoy.